All right, so we just learned how to do the normal curve or normal distribution. The next one is called the standard normal distribution. So that's the extra word, okay? Standard normal distribution. So instead of having the mean plus one standard deviation, the mean plus two standard deviations, the mean plus three standard deviations on the right, and then the mean minus one standard deviation, the mean minus two standard deviations, and the mean minus three standard deviations on the left, they just use the numbers 0, 1, 2, 3, and 0, negative 1, negative 2, negative 3. The purpose of this is that when you're using a normal distribution curve, you can find the exact percentages as long as they're exactly 1 or 2 or 3 standard deviations away from the mean. But that doesn't always happen. What if it's 1.5 standard deviations away from the mean? And you want to know what that percentage is, or if it's 2.3, or if it's negative 1.4 standard deviations away. So you have to be able to do the numbers in between. And if you can't, then this will help you to do that. Okay, so again, the mean is at 0, and then each standard deviation is equal to 1. So positive 1 on the right for every line, and positive or negative 1 on the left, so by 1. So let's go back to the cholesterol example from before. So in the cholesterol example, we have these numbers. So the mean was 172, and the standard deviation was 14. Okay, and so we were able to answer these questions. Percentage of women between 158 and 186, readings higher than 200, and between 172 and 200, because those numbers are all on this normal distribution curve. But let's go back to this equation. So let's say again, the mean is still 172 for the cholesterol problem, and the standard deviation is still 14. Okay, so if we were doing this way, which is fine, we would have 172. The numbers would be the same, right? 186, 200, and 214. And then on this side, 158, 144, and 130. But let's say the question asks, what is the probability that the cholesterol, so a person that has cholesterol, whatever, has a cholesterol that's less than 150? Okay, cholesterol less than 150. So 150 is like right here. So this is 34%. This one is 13.5, but we don't know if it's really cut that far in half. This is because it's not a straight line, it's a curve. And this is 0.15, but this in here, this 13.5%, it's cut obviously more to this side and that side. So if I wanted to know the percentage, and this is 150, 150 is right here between these two, then I don't know that percentage. Okay, so I can't come up with it unless I was guessing. So I can guess that it's going to be, this is like, this is 2.5 and maybe another 5%, so maybe 7.5% if I were guessing, if I wanted it to be less than that. But there's something called a z-score, and a z-score will help you determine that. Okay, so for a z-score, we're going to find the z-score. The z-score will then help us find the probability. So the z-score will give us a number between positive 3 and negative 3. It'll give us a decimal point. So these are z-scores. We're going to get a z-score that's going to be negative 1 point something, because it's between negative 1 and negative 2. So we're going to do this formula. So for this formula, the x we're looking for is 150. Okay, and so 150 minus the mean, okay, divided by the standard deviation. So if I divide that by the standard deviation, which is 14, then my z-score is going to be, let me do this on the calculator, 150 minus 172 divided by 14. This is negative 1.57, but we're going to make a negative 1.6. Okay, that's the z-score. That doesn't mean that the probability is 1.6%. And it definitely can't be negative. So what we do is we look up that z-score in the table. So this table is probably in your book. You can look it up online. It's called the standard normal table. Okay. And so we're going to look that up. There's something that's already been highlighted. That's not the one we're going to use. So we're going to look up negative 1.6. Okay. So we're going to go here. We've got to go to negative 1 first. Use a color other than what they have. So negative 1 is this one. And then 0.6. Okay, so negative 1, 0.6. So we're here. I said 7% or 7.5%. I was a little bit off. This is the probability is equal to 0.0548. I like to look at it as a percentage. So 0.548% probability that they will have a cholesterol that's less than 150. The thing about this table is that it only gives you less than. So if I asked you what is the probability that it's greater than 150, think about how you would find that. I'm obviously going to give you the answer right now, but think about it or pause it and see if you can come up with that answer first. Okay, so the probability that a woman's cholesterol is less than 150 is 5.48%. That means that the probability that it's greater is all the rest of the people. So it's basically 100 minus 5.48, which is 94.52%. So having a picture helps because, again, this table only gives you less than percentages, and you need to know greater than percentages on occasion. All right, so let's go to the next one. The number of seals observed were normally distributed. Okay, so that's important. With the mean, okay, of 73 and a standard deviation of 14.1. And so sometimes I like to draw a picture because you don't know if it's going to fall in the normal distribution curve or not. So the mean is 73. And the standard deviation is 14.1. So we're trying to get to 50. So we're definitely going to go less than this. So if I subtract 14.1 from 73, I'm at 68. So that one would be 68. Let me put those in black for right now. And then if I subtract 14.1 again, hold on, 73 minus 14.1, that's wrong. This is 58.9. I think I did 141 last time, minus 14.1 again. So this is 44.8. So I don't even really need to fill in anything else. It's not on one of the lines, so I know it's not going to be the normal part. So we need this part. And at most 50. At most 50 seals, that means that you can get to 50, but you can't go any more than that. So we need the less than part, which is exactly what we want. So the probability that X is less than 50 is we do the z-score first. The z-score, again, is X minus the mean over the standard deviation. So when we do the z-score here, we're going to have 50. And the answer is going to be similar to what we just did. I don't know if you can see that. It's going to be this percentage. So it should be very close to what we just did. 50 minus 73 divided by 14.1. So the z-score is negative 23 divided by 14.1, which is negative 1.6, which is exactly what I just finished doing. I didn't plan that. But if we look this up again, negative 1.6, and that's 0.058. So the probability is equal to 5.48%. and that's this side, the less than side. Okay. And then for the last one, it says, what is the probability that at least 90 seals? So now we're going in the other direction. So we have 73 plus 14.1. So that's 87.1. Again, I'm using the standard deviation. And then plus 14.1 again. So this is 101.2. So the question is for 90. So 90 is right about here. Okay. And so we're going to do this formula again. Okay. So the z-score is going to be 90 minus the mean, 73, divided by the standard deviation. Okay. And that's going to give me 17 over 14.1. So the z-score is positive 1.2. That's not the percentage. Again, we're doing probability that it's at least 90. So at least 90 means 90 or more. Okay, 90 or more. So this percentage. So you should be able to tell that this percentage is small. It's going to be similar to that one. Okay, but it's definitely less than 50% because 50% it'd be right in the middle. Okay, so this one we want to do greater than 90. Okay, greater than or equal to 90. Okay, so we look up 1.2. We go back to this table. In the table, we go to positive 1 and 0.2, and we see where they meet. So that's 88.8849, 0.8849. That's 88.49%, which doesn't make any sense for our part. The reason why is that the table gives you less than. So the table actually gives you all of this number over here, 88.49. So we need whatever's left over. So we subtract that from 100. So the probability that x is greater than or equal to 90 is going to be 11.51%, which is 100 minus 88.49%. Okay, so it's this part. That's the probability that at least 90 seals were observed during this survey.